Okay, so among all the curves, we now have studied linear curves, or at least understood to some extent. Now we really have to study and understand all the little details about those curves. Because if you look back at what you did in, I don't know, middle school or high school, when you learned about equation of a line, mx plus b, you began studying functions, right? How did you begin studying functions? Did the teacher tell you, well, let us study functions. Here's an equation of a function, y equals f of x. And f can be anything, for example, x cubed plus sine of x minus e to the power x. Did you begin with that kind of function? Probably not. You started with simple functions, right? You chose a simple class of functions, and what type of functions is that? Well, that was probably linear functions. And what did you do about that function, about this class of functions? You not only mentioned, oh, okay, well, there are linear functions. Let's move on. There are quadratic functions, and move on, cubic functions. No, you took your time to do what? To study everything about those functions, right? What did you study? You studied the meaning of m. You studied the meaning of b. You studied a way, or maybe multiple ways, of finding those coefficients if some geometric description of a line is given. Given 2 points on a line, you should be able to find m for the line passing through those 2 points, right? So you spend a lot of time studying that. Well, I would suggest to take the same pattern in everything, in anything you study in the future using calculus. If you want to study a huge family of objects like curves, you take the subset, the subfamily of linear curves, you understand what it means to be linear, and then study in all the possible details everything about those linear curves. What's the meaning of B? What's the meaning of C? What's the meaning of the pair BD? Well, that we discussed. But what's the meaning of B as one number? Does it carry any useful meaning? Can you tell me right now what the B is, what the meaning of B is?
The x component of the velocity vector.
X component of velocity vector, yes. That's one way to think about it. The way I would suggest to think about it is the rate of change of, and now you tell me, of what with respect to what? Because the rate of change is the calculus approach, right?
X with respect to t.
B is the rate of change of x with respect to t, and d is the rate of change of y with respect to t. Okay? And those are the crucial things for our future application of calculus to study curves. Because the next step we take, and that's going to be the end of our study of linear curves in multivariable calculus. We're going to study linear things very quickly. We don't have time to study linear objects. Okay, it's well, basically that's the area of linear algebra. That's where you have to study linear objects. Of course, I cannot delegate everything to linear algebra because it's not a prerequisite for this class, but we will do it very quickly. The essential thing about the curves at this point is the meanings of those two numbers. And now, as we studied linear curves, we go on to the concept of linearization. So